I will put up the question on the slide. It will look something like this. Okay, there will be this is a sample question. You will have a description of the problem, and the question to be answered will be here. And on joinpd.com with the code FKZUKM, you will see the choice and the answer that you have to do. Now, if you're on a mobile, you will see it slightly differently. You will see an answer question box at the bottom right. On the desktop, you'll see a full-blown choice box right there on the right. So here is a few screenshots for you to see. A typical question will look like this. The portion for answering will be there on the desktop, and on the mobile it will be there below on the bottom right. Okay, so you can click on that and answer. So what we're going to do before we start the session is to give you a sample question. This is a test question for me to make sure that everything is working for everybody. I'm going to show you the question. This is a test question. This is not from your graded assignment. And on joinpd.com, you should see this question. And along with this, you will see the options also. You'll see a little box on which you can put in your response.
என்ன பிரச்சனை? நான் இப்ப ஏஞ்சி வந்துடணுமா இப்போ உனக்கு?
So, so we're hearing a lot of private conversations. So please be on mute unless you have to talk. So let me see. Okay, so ensure once again, those of you who are joining in late, please also join on joinpd.com. This is very important for you to participate and respond to the questions that are going to be discussed today, and make it an interactive session. Go in another tab on your browser, go to joinpd.com and enter this code. What is the code? The code is on the right top, FKZUKM. Go there, and then you will be able to see this answer box as well. I think not being able to control the audio is a bit of an issue. So I think one of my colleagues is constantly muting everybody. So we have no option out of it. We'll see. So let's see. Responses are coming in. People are logging in slowly. It's becoming slowly close to 7:30. So once again, welcome to this problem solving session. The way we work in this problem solving session is something different from what you've been doing before. We are connected in two different ways. One is on this WebEx. The other is through something called joinpd.com. Okay. So you go to joinpd.com and enter this code FKZUKM. And then you will see the slide and you will be able to respond to the questions that are asked on this slide. The answer box will come on the desktop itself or at the bottom if you're on your mobile, and you will be able to respond. Okay, so this is a test question to see whether the system is working correctly for you, if you need to change anything to make sure everything works correctly. Okay, so make sure that you look at it. I'm looking at your responses, and wow, there are quite a few people who said 100. That's great. It's great to see. Oh, so there is a spread though. I'll show you the responses once enough people have put in the responses. You'll see at the end how the responses are. So it's good to see people responding. So hopefully it's clear. There's about a minute left. We'll get started in a minute. So let me once again summarize the main mode of operation here. We are connected on WebEx, and I want you to connect also on joinpd.com and use the code that is seen on the right top, FKZUKM. Okay. And then you will be able to answer questions like this on the browser for me, and I'll be able to see your answer. So every slide will have some interaction like this. You will have to enter something, and we'll summarize what's going to happen. Okay. Okay. All right. Okay, so it's 7:30. We should officially get started. Welcome each and every one of you. I'm really happy to interact with you in this problem solving session. So far, we have not really had an opportunity to discuss graded assignment problem with you. We have not been doing that so far, but we're going to change that from this week onwards and try something new. So we're going to discuss questions that are very similar to graded assignment questions in these dedicated problem solving sessions, which will work in an interactive manner. Okay. How are we doing it? Once again, I'm repeating for those who entered a little bit late. This is a test problem. If you go to joinpd.com and enter the code FKZUKM, you will be able to see a way to answer this question. Okay, this is a test question. This is just a sample question just to see that everything is working. Hopefully, it's working for you. You have been entering your answers. So let's see the answers. There's a chance for me to even show you what the answers are. This is the spread of the answers. Can you see? So you can see the spread. It goes all the way. I mean, quite a few people have said 100. Quite a few people have said 75. 70 is a popular number. And it's coming in as we speak. The answers are coming in. I request everyone to please be on mute if you're not on. Somebody's saying 101. Wow, they're so confident. Okay, let's change it to 100. Yes, good to see the confidence. Thanks for keeping the response coming. Oh, 140. Okay, please don't. I think that's just a joke. So let me hide the responses. Thank you very much. It's quite a good participation for this session. Please mute your mic. I'm requesting Balaji to keep muting everybody again and again as much as possible. Okay, so we're going to jump into the first problem. The first problem is very similar to one of the graded assignment questions. It's on even and odd functions. Okay, so there's a function that you see on the screen, and it's just a sketch, a rough sketch. You can sort of take it to scale and make sure that it's exact in some sense. It's given between -4 and 4. That's the function for you. And the question that is asked is this function even or odd or neither even nor odd? We know that all functions will fall into one of these three possibilities. People want me to explain once again. Once again, for those who came in late, you are connected on WebEx, that's great, but also go to joinpd.com. You go to joinpd.com and enter the code FKZUKM. Okay, so I put here joinpd.com and the code is FKZUKM. Okay, it's on the right top. Use that code and you should be able to give your answer. Everybody is able to do it. Please debug on your side if you're not able to do it. So this is the first question, and I'll give a few minutes for people to respond. This is quite a simple and easy question to get started. Quite a few people are already responding. It's good to see. And after some time, I will go and look at the responses as well. Okay, I'll give you 2 or 3 minutes to look at it, look at the definition, and give your answer. Okay. Don't put answers in the chat box and all that. The answer should go only into the joinpd.com. Don't put it in the chat box. Go to joinpd.com and enter the code FKZUKM and then put in your answer. Okay. I'll give a couple of more minutes. If I can see about okay, recall the definition of even or odd functions, or neither even nor odd. You can go and recollect what it is. I'm not down the definition here, so in the solution when we discuss, we'll do that. Okay. This is part A of one question. In exactly 1 more minute, I'll move off to the part B, which is another function. Okay. Okay. So let's quickly see the responses and then go over. Overwhelmingly, a large number of people have said the function is even. About a small fraction is saying it's odd, and a smaller fraction, very small fraction is saying odd, and a slightly larger fraction is saying neither even nor odd. Okay. So when I discuss the response, I will give some more highlight to what this is, and I think most of you by now should be convinced the answer is even. Okay, that's what it is. We're going to move to the next question, second question, part B of Q1. Okay, this function, this is a different function from before. We have f2 of x. Is this function even or neither even nor odd? Okay, so that's the question. Please keep your microphones on mute, please. So to answer the questions, once again, I'm repeating, go to joinpd.com. In WebEx, you cannot answer the question. You go to joinpd.com and put in the code FKZUKM. That is the code, okay? FKZUKM. If you put in the code, you'll be able to answer the question. Okay, a lot of people have figured that out. Okay, so responses are coming in. Plenty of responses are in there. Okay, that's good to see. So this is a very standard question. Given a function, you have to identify whether it's even or odd. Okay, I'll give it 1 minute or so, and then I will look at the responses and go towards the solution. Okay. Okay, just 1 more minute. We're exceeding time a little bit, but that's okay. There are enough people joining in a little bit late, so once again, if you're joining in late, also go to joinpd.com. Go to joinpd.com and put in that code that you see on the top right. Okay, FKZUKM. That is the code. Okay. All right. All right. That's 1 minute up. So let me show you the responses. An overwhelmingly large number have said that the function is odd. Sort of equal number, a small fraction have said even, and then neither odd. They see the correction now, and then they're going and correcting. I think that's okay. I think it's okay to be confused at this stage. As you keep learning, it will improve. All right. So now the time comes for a solution, and also to tell you about how to go about thinking of these kind of how to go about answering these kind of problems. Okay. So the goal is to identify even and odd functions, isn't it? Given a function, how do you say whether it's odd or even? Okay. There are two cases I'll consider. The first case is when the function definition is given explicitly. Okay. Explicitly, the function is given. So, for instance, f of x could be x cubed or x power 4 or x power 10 or something like that, right? So, in that case, all you need to do is to find f of minus x. Okay, wherever you have x, you put minus x. So, you get f of minus x, and then look at what you get. Okay, this example also shows you what to do. You look at what you get. If you get minus f of x, then it is an odd function. If you get f of x itself, it's an even function. If you get neither, it can happen that f of minus x is neither equal to f of x nor equal to minus f of x. That can also happen. If that happens, then it is neither even nor odd. Okay, so this is one way in which this problem can be asked. Okay, but in your question, the question answer was not like this, right? I hope I'm audible. I thought that somebody said I'm not audible. Balaji, can you hear me? I'm audible,
yes,
right?
Sir, you are audible, sir.
Okay, thank you. So the question given for you is slightly different, right? So what is the question that's given? The question that's given is a sketch of the function. You're not given the exact function itself. It's just a sketch. It's a rough sketch. You can sort of imagine that it should be an accurate sort of sketch. So if a rough sketch is given, you have to look at symmetry. Okay, so there are two ways in which you have to look at symmetry. One is so what is symmetric about the y-axis? You sort of imagine a paper in which this function has been plotted and fold it about the y-axis. Okay, you keep the y-axis in one place and then you fold the paper about it. Okay, the y-axis is your edge. Okay, on that edge you fold it. If the two curves are going to coincide, it is symmetric about the y-axis and you have an even function. Okay, so if you notice f1 of x, if you take that paper and fold it with y-axis as the edge, okay, you will see the two curves will coincide. It becomes even. Now, on the other hand, f2 of x, you see that it's not going to coincide, right? The f2 of x on the x positive side, x positive side will go down, right? Go to the third quadrant, while f2 of x on the negative side is on the second quadrant, right? So it's not going to coincide. So it's not even. But is it odd? How do you find it's odd? For that, you have to look at the minus thing. Okay, so what I would do is I would take the positive part of f2 of x and first flip the positive part alone about the x-axis. Okay, so that gives you the minus f2 of x, right? And then you check for symmetry on the y-axis. Okay, so if you flip it about the x-axis, only the positive part, okay, only the f2 of x for x positive, you flip it about the x-axis first, and then it will go up, and then you see the symmetry, right? So if that happens, then it is odd. Okay, so hopefully these two situations are clear to you. If neither happens, okay, neither of these things result in the curves coinciding, you get neither even nor odd. Okay, so that's what is the solution. Hopefully this was clear. So if the sketch is given, this is how you do it. If the function itself is given, you simply put minus x instead of x and see if you get f of x or minus f of x. Now there is an answer box in this slide also. Okay, so if you have any doubts on this, please put it in the chat box. I will look at it a little bit later. But there is an answer box in this slide also. What I want you to do is type an example of a polynomial. Okay, type an example of a polynomial which is neither even nor odd. Okay, I want you to type it into the answer box. Okay, that's the question I want you to answer. Type an example. So there were two examples that we saw here. One was an even function, the other was an odd function. As an additional question in this slide on joinpd.com, I want you to type an example of a function which is neither even nor odd. Okay. So I think I see responses coming in. These are free flow text responses. So let me just show it to you. It's better to. A lot of people are doing this. So I want you to type an example of a function which is neither even nor odd. Okay, so there's an example: x cubed plus x squared. Yeah, so it's got the right idea. Log x. Log x is a bit difficult, right? Minus x, it's not even defined. So let's not go into such kind of functions. Yeah, x squared plus 2x plus 4. There's so many of these functions which are neither even nor odd. 5 minus 3x, yeah, absolutely, neither even nor odd. A lot of functions are there which are neither even nor odd. Okay, think about it. I'll leave you with one thought before I go look at the chat box for any questions that may be there. It turns out that any function can be written as the sum of an even function and an odd function. Okay, any function can be written as the sum of an even function and an odd function. Okay, so think about how you would do it, and this might be a surprising thing for you. Even an odd seem like very peculiar type of function. Then any function can be written as a sum of even and odd function. So it's an interesting little fact. So quite a few people have responded. I mean, unfortunately, I can't really browse through the whole thing. So hopefully it's. I think most people are giving correct answers. It's difficult to browse through and check everything. But thank you very much for participating. So that's what I had. Okay. So we are exceeding time a little bit. This will be maybe 2-3 minutes. So let me just quickly go to the chat box and see if there are any interesting questions. Can you send the code for join PD? Okay. First question doesn't look like a smooth curve. Yeah, I mean, I guess the sketch you will sort of take approximately. It's difficult to do that. Okay. If a graph is symmetric about y-axis, if you have a curve. Okay, so wow, Naveen has given you the answer. Sort of. Okay, constant function is even. That is correct. Graph is symmetric about y-axis. It's even. Yes, it's not also even. It's even. Can a discontinuous function be odd or even? I don't think continuity matters. It's just a function, so it should be okay. So is the voice very low? And I do have a mic and I'm talking into it, so it should be okay, I think. Though it has a corner and all doesn't matter, I mean, so f of x has to be equal to f of minus x. That's all that matters for even an odd function. Equation of any line, yeah, okay. Okay, so I think Harshavardhan has given an answer of the split of f of x into odd and even. That's very nice. That's the correct answer. Modulus function is actually an even function. Uh, x equal to 2 is neither even, no, x equal to 2. What is x equal to 2? That's not even a function, right? See, you have to give a function. You have to give f of x is what? Are you saying f of x is 2? If f of x is equal to 2, that's an even function. Trigonometric equation. What is trigonometric equation? See, we are thinking of a function, f of x. Okay, x is a real number and f of x is a function. So define f of x. For x, what is f of x? You have to say that. If you say that, then we can try and answer whether it's even or odd or neither even nor odd. Okay. What if a function is symmetric about x-axis? See, if it's symmetric about x-axis, it's not even a function, right? See, what do you mean by symmetric about x-axis, right? So what is on top of x-axis, there should be something on the bottom also. So for a particular value of x, you will have two different values of the f of x. So those are not proper functions. We can't deal with that, those kind of functions. Okay. Uh, so be careful. See, function f of x is function of x, right? So that's it. So nothing more. Okay, we're out of time. We've taken 16 minutes for the first question. We can't go out of time. So we're going to move on to the next question, question number 2. Thanks for participating in the chat, everyone. Thanks for being part of this. Here's the second question. Question 2A, okay, A part of the second question. This is also very similar to the graded assignment question. So this question asks you to imagine a roller coaster ride, excuse me, for the where the curve of the coaster as such, you know, the railing that you have in the roller coaster is defined by a polynomial function. Okay, that polynomial function is given to you x cubed plus 2x squared minus 25x minus 50. Okay, and the domain is given as minus 5 to 5. Okay, so look at the question. The question that's asked is how many bends are there in the roller coaster? Okay, if you imagine a roller coaster along that curve, and you have to sort of answer how many bends are there. You know, roller coasters sort of go up and then come down. They come down and they go up. Okay, so those are called bends. And how many bends are there in this function? So the way to think about it is you have to sketch this curve, right? This cubic polynomial f of x equals x cubed plus 2x squared. Don't put the answer in the chat box. I'm not going to look at the chat box. It doesn't count for you. Go to joinpd.com, enter the code FKZUKM, and then you will see the slide and you'll be able to answer the question on the slide. So please do that. And this is sketching the curve question. Let me give you a couple of minutes more, and then we'll start looking at the answers that are coming in. Okay. So try to sketch the curve. The way to sketch the curve, I'll quickly talk about. People are still asking how to submit the answer on joinpd.com. You just go to joinpd.com and enter this code. You will see the slide, and the slide will have a way to answer the question. Okay, if you're on a desktop, you will see you'll see a box which has an answer, and if you're on a mobile, there'll be a bottom part. If there's any issue, just reload that page. Okay, keep reloading that page. It should work. Okay. Okay, so let's help each other out. I know people are upset if they can't participate. It's a natural feeling. Let's help each other out and not be upset about things that are happening. Okay, there's no enter or anything. You just enter and put the number in, and then click somewhere out of the box. You're done. Okay. So I see quite a few responses are coming in. I will stop it after a minute or so and show you the response. The code is on the top right of this page. It is FKZUKM. Yeah, thanks Hariteja for putting that in. Please help each other out on the chat box. Okay, so these kind of questions are very important. Ability to sketch a polynomial, understand its peaks and for the places where it hits the bottom, roots where it hits the x-axis, These are extremely crucial and important things and skills to have. Okay, all right. So that's 750. So let me show you the responses that have come. Quite a large number of people have said 2, and there are quite a few people who are outside of that. So what we'll do now, 2, as it turns out, as you can guess, is the correct answer. But I will show you the solution. But there is a part B to this question. So let's go to the part B of the question. Quickly finish that, and then we'll discuss the solution in some more detail. Okay, so this is part B. Okay, take a look at this, the same setting. The question now says, how many times does the roller coaster reach the same height as that of the starting point? Okay, x equal to -5 is at a certain height. Height is just f of x. Okay, and you have to include the height of x equal to -5. How many more points, including x equal to -5, are at the same height? Okay, how many points are at the height of x equal to -5, including -5 itself? Okay, that's the question. Hopefully it's clear. These are similar to the question that's there in the graded assignment. Don't put the answer in the chat box. Put it on joinpd.com. That'll be nice. Don't spoil. Help out friends in the chat box who are asking for the code and all that. Those who are joining new to participate and answer this question, go to joinpd.com. That's the site you have to go. You have to enter the code FKZUKM. If there is any issue, reload the page. I think maybe the traffic is a little high. I don't know today. So I'll give you one more minute. We don't have too much time for this question, and I want to discuss the answer in some detail. So include x equal to -5. Okay, so already there is 1 point which is at that height, and you'll have how many more points, and what is the total number of points at that height? Okay, so that's the question that is asked. Okay, so let's see the responses. 3 seems to be a very popular number, and quite a few people are at 2. That could be because of the misreading of this question, which asks you to include x equal to -5. So 3, it turns out, is the correct answer. So everything hinges on our ability to sketch polynomials, sketch cubic polynomials. How do we sketch cubic polynomials? Let me quickly walk you through the main steps involved in sketching. Okay, so before I even start, I have to tell you that today, if you have to sketch outside of the exam hall in your house or in your office, there are hundreds of computational tools. You can even get Google to sketch it for you. I know that's true. It's a practical reality today. You should know that as well. You should have a good computational tool on which you can sketch any function. I would recommend Desmos. There are so many others as well. Have a good tool, but in the exam hall, you don't have access to those tools. So you better know how those tools work, right? How is it internally that they're working? Okay, so this is how you can go about doing it. We'll mostly consider easy cases in this course. And the first thing in the easy course is to factor the polynomial and identify the roots. Okay, so this is sort of, I mean, it's the most natural thing to try for any polynomial, and you should try that first. Okay, so I'm talking about easy cases where this factoring is very easy. Okay, in case it's not easy, you may have to fall back on a computational tool. Okay, so otherwise, this is easy to do. So in exams, this trick is important to learn. Okay, so try to group the first 2 terms and the last 2 terms so that you get a common factor. Okay, so this is the grouping terms factorization. It's a very common approach for exams. So you can see here, if I pull x squared out, I get x plus 2. If I pull -25 out of the last 2 terms, I get x plus 2. So this is sort of, I mean, you should sort of eyeball it and see it and do it. Once you do it, then x plus 2 becomes common. You pull that out, you get x squared minus 25, and the whole thing factors completely into what are called linear factors, degree 1 factors, right? So x minus 5, x plus 5, x plus 2. I'm reordering it and writing it in a different order so that I get the roots in sequence. When is this polynomial 0? What are the roots of this polynomial? What values of x will give you 0 for this polynomial? Once you have the factorization, it's a trivial thing to answer. Okay, so x equal to -5, -2, and 5. Okay, so the roots are very crucial. So that's the first step. Okay, hopefully most of you got this first step. This is the first step towards sketching. Okay, finding the roots, places where the polynomial hits 0. Okay, first step. Second step is what happens in between. Okay, at -5, I know it's 0. At -2, I know it's 0. At 5, I know it's 0. What about in between? What about values less than minus 5? What about values between minus 5 and minus 2? What about values between minus 2 and 5? What about values above 5? It turns out you can find out whether the polynomial is positive or negative in each of these intervals by simply looking at the sign of each factor and looking at the product. Okay, it's a very easy elementary thing to do. Just take a look at the numbers. Okay, I'm going to show you only one case. The other cases are very, very easy. Okay, don't worry, you'll get these slides. All these slides will be available to you. Don't worry. Okay, so x less than minus 5, you can quickly check. If x is less than minus 5, x plus 5 is negative, x plus 2 is negative, x minus 5 is negative. All three terms are negative. Multiply together, you will get negative. Polynomial is negative. So for x less than minus 5, it's going to be negative. So between minus 5 and minus 2, likewise, you can show it's going to be positive. Between minus 2 and 5, it's going to be negative again. Again, how do I do this? Just look at the sign of each of the factors, then the product. Okay, so it's a very easy two-step thing to do. And finally, x is greater than 5, it's going to be positive. Oh, yeah, all the factors are positive and the polynomial is positive. Okay, so once again, let me repeat the two steps. Find the roots. We will give you easy cases where you can find 3 real roots quite easily by grouping the terms. After you find the roots, figure out what happens between the roots. Okay, what happens between the roots is also crucial. Once you know these two things, polynomials are easy to sketch. Why is that? Because polynomials are sort of smooth between the peaks. Okay, so the sketch will look like this. There's minus 5 where it hits 0. There's minus 2 where it hits 0. There's plus 5 where it hits 0. And you saw to the left of minus 5, the curve is going to be negative, right, below the x-axis. Between minus 5 and minus 2, the curve is going to be positive. So now what should happen? Like I said, polynomials are smooth, right? If you have to smoothly go up and come down, right? Because you're going from 0 to 0. Minus 5 is 0, minus 2 is 0. Between it's positive. So it has to go up, bend, and come back. So that's the first bend, right? Between two roots, there is a bend, a peak up on top and coming back. So that's one bend for you. Okay. Then between minus 2 and 5, minus 2 and 5, it's negative, but at minus 2 it's 0, for 5 it's 0. So it takes off in the negative direction, goes down, 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 and it has to bend and come back to 5. Okay. So you have bend number 2, bend number 1. So there are 2 bends. Okay. So in general, these things can be generalized in any polynomial. If you have roots like this, in most cases, you'll have these kind of bends. Okay. So these are all nice results to have. Okay. So sketching is very important. Once you sketch, everything can be answered, right? So what was the next question? You look at, part B, right? Part B was, how many places are at the same height as minus 5? Minus 5 is at 0, okay? Minus 2 is at 0, plus 5 is at 0. So you have 3 different points at 0. Okay, so Q2A answer is 2 bends, and Q2B answer is 3. There are 3 points total at the same height as minus 5. So this is a roller coaster. I don't know if there's any real roller coaster like this, at least in your Math 1 course. You've been riding a roller coaster so far, so this is probably one of the easier roller coasters for you than the other ones in the class. Okay, so the question I want you to answer in this slide, okay, I want you to think for a couple of minutes. We're really out of time. I want you to think about how you will find the location of the peaks. Okay, excuse me. How will you find the x at which the first peak occurs? How will you find the x at which the second peak occurs? Okay, think about it. This is an interesting problem for you. If you have any ideas, you can put it in the responses. Okay. While you put in the responses, I'm going to go look at the chat box and see if there are questions that I have to answer. It seems like a lot of questions. Okay. Oh, this is too many questions. So there are so many questions, it's very hard. And people are continuously typing. Don't type the answer in the chat box. Put the answer in the joinpd.com. Ask only questions here in the chat box so that it's easy for me to find the question. Okay. Smooth here mean function is differentiable. I mean, we're not talking about derivative and all that in this class. Smooth is just smooth, I mean, you can just sketch it without lifting your pen, for instance, right? So simple definition. Let's not ask too many complicated questions. What if a function has complex roots? Okay, so that's a situation I haven't spoken about If the function has complex roots, it's a little bit more complicated. Some people will say complicated, some people will say easier. Okay, so let's not worry about that in this class. I'll leave that to you as a challenge or an exercise for you. Take a look at those kind of situations. Those are complicated. Okay, slightly more complicated ones. Okay, explain the concept of stretch factor. Oh my God, what stretch? I think we're talking about that here. Factorize the quadratic equation, then I got all three roots. Yeah, it's also fine. You can do roots in so many different ways. Uh, you can check out something called the rational root theorem. You've not seen that before in your life. It's an interesting little theorem for you to see. Just searching, I think it's difficult for me to search questions in this chat box because people keep typing on the, okay, why is the curve negative between -2 and that's why I was disconnected. Okay, so you have to look at the factor and find the sign of each factor. I'll share these slides with you later, and then you'll be able to do it. Okay, so the factors, there are three factors, and just look at the sign of each factor in that range of x, and then you'll know the sign for the whole polynomial. Okay. How did you figure out the curve starts from minus infinity? Oh, the x-axis sort of goes from minus infinity to plus infinity always. So the moment I say f of x, it always starts from sort of a minus large number to plus large number. Okay. Seven lecture, number of turns is one less than number of roots. Yeah, those are all nice simple formulae. I'm just giving you sort of a logical explanation for why those formulae come. Okay, we'll take just one more minute. One more minute. I think it's 8:01. Maybe I'll take just one more minute to see if there's any nice question. Would tangent be zero at peaks? Yeah. Those are all exactly correct. Slope equal to zero. Yes, that's a good way of finding the peak. Very good. Okay, all right. Okay, so Ayush Kumar is talking about multiplicity of the zeros and all that. So yeah, there are quite a few advanced ideas in how the roots will behave. We are not discussing all those cases in this class. I will leave that to you as an exercise. I mean, try different cases, right? So for instance, what if you have x plus 2 whole squared times x minus 5 instead of x plus 5, right? Plotting that on Desmos or any of your graphing calculators. You'll see, I mean, just keep fooling around with it. You'll learn a lot more on your own, okay? All right, we have to go to the next question. We are done. Question number 2, 15 minutes are up. So let's go to question number 3. Okay, thanks a lot for your participation. Let's go to question number 3. Q3 is right here. Okay, I'm going to give you 2 minutes and take a 2-minute break and catch my breath. I've been talking continuously. So let me take rest for 2 or 3 minutes, let you solve the problem and enter the answer. Once again, for those who have joined late, go to joinpd.com, enter the code FKZUKM. It's on the right top here, and then you can participate and answer questions as well. Okay, don't put the answer in the chat box. Please respond in joinpd.com. So the slides of this discussion will definitely be shared with you. Don't think that's in the slide. The slides will be shared with you. I believe it's being recorded also. Balaji, can you confirm that the recording is being done?
Yes, sir. It is live streamed in YouTube, sir. It will be published right
Available
away.
on YouTube. Oh, okay. Sure. So if you've joined late, can somebody help out Maitri on how to joinpd.com? Please help each other out on the chat box if people are joining late. Okay, so there are, I'll give you one or 2 more minutes, 1 more minute at least. So responses are coming in. We've got more than 150 answers so far. And, okay, people are typing in the answer very, very fast now. So we'll give us a little bit more time. 1 more minute. Okay, last minute. Please enter your answers. Quite a few have entered already. Okay, so let me show the responses. Uh, okay, one seems to be the most popular answer, and that's correct. Okay, so the correct answer is one, and let's see how to get there. Thanks again for everyone who worked out the problem with us and submitted it. It's great to see. One is the correct answer. Quite a few of you have got it right. So let's just quickly see how to get to one. Okay. So this question is about finding a point where two curves meet. Okay, so there are two curves that are given to you, right? Both are cubic polynomials. One is like the rate at which the concentration, what is it called? I forget. The amount of one molecule or one type of chemical that's there in the reaction. The other curve is the amount of the second chemical that's there in the reaction. One is reducing, the other is increasing, and they will sort of meet at some place. Both these curves are cubic polynomials, and you need to find the point where they intersect. Now, at the point where they intersect, if f1 of x and f2 of x are intersecting at some point, then f1 of x equals f2 of x at that point, right? So how to find out all points of intersection? Simply equate the two equations and solve for the unknown in the equation, right? So this is equation solving directly from the polynomial. So you have one polynomial being 2t cubed minus 2t squared minus 42t is 90, then 2t cubed plus 2t squared plus 44t. This quickly cancels and you get wonderfully a quadratic equation. And I'm going to assume you know how to solve this quadratic equation. It's possible to solve it in multiple ways. You can do it by sort of splitting the middle term and grouping factors, or you can directly use the formula, right? So this is just is my volume okay, Balaji? You're able to hear me
Sir,
clearly?
very fine, sir. It is.
No problem, right? Okay.
No problem.
Okay. All right. So so you can use a formula. You know, you just do that. You'll end up getting two different answers. One of them will be quite meaningless, like minus 45 by 2 is quite a meaningless answer in this context. You can pick t equals 1 as the correct answer. Okay, so you get t equals 1. It's very simple in some sense, but sometimes a situation can get a little bit more complicated. So in this slide, you have a box. What I want you to respond in this box is, it was very convenient that t cube got cancelled in this, right? So you're able to easily solve the quadratic and you get it. So in case t cube does not cancel, right? Supposing it does not cancel, what will you do? Okay, so think about that and put that as a response to this slide. Suppose t cube doesn't cancel and you have a cubic equation here. What will you do to find t? Okay, is that okay? So that's what I want you to answer here. We'll come back and look at the responses. In the meantime, let me look at the chat box to see if there are any questions. Okay. Don't answer my questions in this chat box. Please go to joinpd.com. It will help everybody here, because we can keep this chat box just for questions. It's easy. Okay. People are continuing to type here. Let me just see. We consider complex roots as roots in polynomials are not in our syllabus. Okay. So far we have not talked about complex roots and all that. So you will not be expected to know complex roots as part of the syllabus here. Okay. Okay. So there is information on how peer debt should be used. Yeah, sure. How do we account for? Given the roots are fixed? How do we account for rotational possibility of the sketch of a graph? So rotational possibility doesn't seem like a very precise question to me. So maybe you can clarify that later. Being asked to drink some water. Catch me. Okay, all right. So it's not too many questions. So let's see what people have responded to. Factorize the cubic equation. We'll first find zeros by trial and error, and then we may divide. Yeah, exactly. So no need to worry about cubic equation, right? Cubic equations are easy to solve. Of course, in an exam, you'll have to try one of the methods we discussed earlier to try and factor, etc. So in the in like I said, in practice, if you're doing it in your job or at your home, factoring polynomials is very easy. Okay, so it's a very easy operation. You just give it to any computation tool, it will give you the answer. So you can do that. There's no reason to be worried about cubic polynomials. But what will happen? What's interesting is, as the degree of these polynomials keep increasing, they will start intersecting in all sorts of interesting ways. Okay, so that's the points at which curves intersect is a fascinating topic in mathematics. If you are interested, you can pursue that later on of your own volition. Okay. All right, we're doing great on time. So, in fact, we finished 3 questions and we are less than 45 minutes into the discussion. It's great to see so many people still around and enjoying the session. Okay, so let's go to question 4. There is question 4. Once again, I'll leave this question with you for a few minutes, and this is a multiple choice question. So once again, the box for answering would have come up on joinpd.com. Please go to joinpd.com and join with the code FKZUKM and give your answer there. Okay. Okay, quite a few responses have come in. I guess multiple choice questions are easy to respond to, isn't it? So one can quickly pick one of the 4 topics and eliminate one of the 4 answers, eliminate the other answers. that makes MCQs quite easy, and you can also go wrong. So let's see. I'll give it a few more minutes and then show you. It should work. Somebody is asking what's going on here. So if you're joining in late, we are solving problems together. The problem that you see on screen, you have to solve. And you have to go to joinpd.com and enter the code FKZUKM, and then you can enter the answer to this question and then see it. And right now, I'm giving time for people to answer the question. Okay, I'll give 1 more minute. Quite a few responses have come in. Yes, it's a single choice. One of the 4 answers is correct. That's what I'm told. People have their own interest. All right. So now the time has come for me to show you the responses. Okay. So here's the response, and there's a huge number of people who have said degree of g of x. That is the correct answer. A few of them have given other answers: 7, degree of g of x minus 1, and 4, etc. So thanks a lot for responding. Let's now go in and see how to think of this problem, how to go ahead and solve this problem. Okay. So now everything is about polynomial division, right? So in particular, given a description of the scenario, how do you find degree of remainder? Okay, so that's the question here. So let me just recall, first of all, dividing one polynomial by another. You might have learned it long ago in school sometime. You put one polynomial inside, put the other polynomial outside, and then you divide, you get the quotient and you get the remainder. So what is crucial is when you divide a of x by b of x, you get a quotient qx and the remainder rx. And a of x equals q of x times b of x plus r of x. That's okay. What is crucial here? Degree of the remainder has to be strictly less than the degree of what you divided by b of x. So in this example, what you divided by is x minus 3. So the degree is 1. So what should be the degree of the remainder? 0. Right? So it should be, of course, the remainder itself could be 0, in which case, you get, but you can even have 5. Okay. So this example sort of tells you how division works. Right? So this is just to tell you division. It turns out division of polynomials is sort of similar to division of numbers, of integers, your regular division with remainder of numbers. A lot of properties, interesting properties, are shared by them. Okay. So here are some properties. What are the important properties that are crucial for this problem, for solving this problem? Here are the properties which will help you. Okay. First is, what is the meaning when we say b of x divides a of x? When do you say one polynomial divides another polynomial? Okay. When do you say one polynomial divides another polynomial? When you say that, you take a of x, divide by b of x, if the remainder is equal to 0. Okay. So one situation is remainder is equal to 0. So that's one possibility. If the remainder is non-zero, its degree is going to be less than the degree of b of x. I know that for sure, but the remainder itself could be 0. That's one possibility, right? So that can happen. If that happens, then we say b of x divides a of x. So this is a statement: b of x divides a of x. That's what we say. Okay. It seems like overuse of the word divide, but that's sort of accepted terminology. People understand. So that's the first concept. Notice what else can happen. So supposing what you are dividing by has degree strictly greater than the degree of a of x. Okay? So you're dividing a of x by b of x, but the degree of b of x is greater than degree of a of x. Okay, so I have a typo here. It's a huge typo. Sorry about that. So if the degree of b of x is greater than degree of a of x, what is the typo? Anybody identified the typo here in this slide? What is the mistake? I made a typographical error here. What should the remainder be? It's not b of x, it is a of x, right? Absolutely right. So Srinivas has found out. So r of x here in the second property here, the remainder r of x is a of x. Okay, so the degree of b of x is greater than a of x, and we're dividing a of x by b of x. Remainder will simply be a of x. There's no division to do, right? So you just directly get the answer. There's a typographical error. Apologies for that. There's no way, I think, for me to correct it right at this point. So I'll correct it later before distributing this slide. So this is a of x. Now the third property is maybe slightly non-obvious to you. If you have the sum of two polynomials, a1 of x plus a2 of x, excuse me, and you're dividing the sum by b of x, okay, is there a connection between that, the remainder you get when you do that, and the remainder when you get when you divide a1 of x by b of x, a2 of x by b of x, okay? So it turns out there is a very simple connection. What is the connection? Supposing you divide a1 of x by b of x, you will get, let's say you get a remainder r1 of x. And then you will divide a2 of x by b of x, you will get another remainder r2 of x. It turns out if you divide a1 of x plus a2 of x by b of x, you will get a remainder r1 of x plus r2 of x. Okay, this is not very difficult to prove actually. You can sort of take the formula and sort of add it up and you'll quickly get this. Okay, so if you have the sum of two polynomials, you can divide each one individually by b of x, find the individual remainders, then add up the remainders at the end. Okay, so this is also something that you can do. So these three properties are properties of the division. And okay, once again, I want to remind you about this typo. The second property is r of x equals a of x and not b of x. Okay, you can use all these three and solve the problem. Okay, once you use all these three, it's very easy. So we're given h of x divides f of x, and degree of g of x is less than degree of h of x. Okay. Now, what happens when f of x plus g of x is divided by h of x? You use the third property from before. You first do f of x divided by h of x separately, but h of x divides f of x. So when h of x divides f of x, what happens when you divide f of x by h of x? Wow, I'm saying f of x, h of x, g of x. I'm sure for some people head is spinning. Apologies for that. Read through the slide slowly, you will understand that. If you divide f of x by h of x, you will get a remainder 0. Why is that? Because h of x divides f of x. And then if you divide g of x by h of x, notice what's going to happen. Degree of g of x is less than degree of h of x. So division will have no impact and you'll get the remainder g of x itself. So in fact, in this problem, when f of x plus g of x is divided by h of x, you will get the remainder to be equal to g of x itself. So once you get degree g of x as a remainder, the degree of the remainder is easy to answer. The maximum possible degree is a degree of g of x. Okay. Hopefully that was clear. Now, I want. So I have a question here for you. Additional question. My additional question is: supposing one of these conditions is not given. Let's say we are not given that degree of g of x is less than degree of h of x. Okay, let's say we are not given that. Okay, is that okay? Hopefully it's clear. All right, so h of x divides f of x, that's okay. But then degree of g of x is less than degree of h of x, right? So that I don't give. Let's say I don't give. Okay. All right, hopefully it's clear to you. What is the answer to this question? Okay, can you say anything intelligent about this? So you've given h of x divides f of x, that's okay. But this degree of g of x being less than degree of h of x, that information is not given. The other information is there. There's one more information, right? I forgot what it is. I think degree of f of x and degree of g of x are equal, right? So that's also there. But this g of x less than degree of h of x is not given. And what will happen? Okay. So while you answer that, let me go look at the chat box and see if there's something interesting there is something interesting. Let's go on there. Please arrange to remove the advertisements from the lecture. Oh, okay. Oh my God. So people are typing into the chat box. Please don't type into the chat box now. If you want to type something, go to the join PD and type. Nobody's going to listen to me, right? Okay, it's very easy to remove the ads. Oh my God. How come degree of remainder is equal to degree of quotient? It's never possible. It's true. Okay, people are not allowing me to see the previous chats. I think they're just continuously typing into this chat window. Let me see if I can go in and do something here. Uh, okay. Does division of one polynomial by another polynomial always result in a polynomial? Yes, of course, absolutely. Okay, so that's how division is. In fact, it results in two polynomials, right? It results in the quotient and the remainder. Okay, so that's how division is defined. Go back and brush up the basics there. It's very important that you're comfortable with this notion. Okay. Okay. Second property. Okay. Second property, somebody wants a brief explanation. So let me just see. That's, I think, all I can do. We're running out of time also. The second property was what? I forgot what the second property was. Let me just quickly go back and check that. Degree. Okay. So it's like saying second property is supposing you have, say, x plus 1. Okay. No, not x plus 1. Take x plus 1. Supposing you divide x plus 1 by, say, x to the power 10 plus x power 5 plus 1. Okay. So already you have only x plus 1. You're dividing that by x to the power 10 or something like that. Very big degree polynomial. What will be the remainder? It's going to be just x plus 1, right? There's nothing to do. Quotient is 0 and remainder is that polynomial itself, right? So that's the idea behind that second property. And that's easy to do. Okay, now let me just see the responses here. We're typing degree of g of x minus 1. Okay, so, all right, so that seems like a degree of h of x minus 1 also I thought was okay. Okay, wow, lots of answers are coming. Okay, if the answers are so complicated, it's yeah, so degree of h of x minus 1 seems like a very tempting answer. Quite a few people have given that. So yeah, so it's difficult to say, right? So it's given h of x divides f of x, and I think the question said, what else did the question say? The question said degree of f of x and h of x are equal to 7, and degree of f of x is greater than degree of g of x. Okay, so all these things the question said. Okay, remember all these things. So you put all those together and then you divide by h of x. You can say something slightly better. Yeah, so I think degree of g of x minus 1 seems like I mean, it's difficult. It becomes a little bit more generic, isn't it? So at least people are attempting it, and I'm happy that people attempted it. So 175 if you answered it. So that's good. Okay. All right. So I think we're done with the time that we had for this question. We're off to the last question of the day, and with that, this session will conclude. Quite a few of you have stayed with us throughout the session. Thanks a lot for that. So let's move. Okay. So this questions are coming in the chat box. The problem with the chat box for me today is people are typing at such a furious pace in the chat box that they just type everything. So and it won't divide. It is a reminder with having the power. Okay, so it's yeah, the denominator. So you're dividing one polynomial by another, then the degree of the remainder is less than the polynomial with which you divided. Okay, so don't think of numerator denominator. We're not thinking even of fractions at this point. Okay, so think about this, right? There's no negative degree or anything. All our polynomials are positive degree. Okay, so think about this other question I asked you. maybe you can post the answer. All right. So we're coming out to the last question of the day. This is again a question which is from your very similar to the one, or maybe exactly the one that's in your graded assignment. Once again, I'll give you about a few minutes to look at this question and enter the answer on joinpd.com. So those of you who came in late, this time is for you to go to joinpd.com, put in the code FKZUKM, and then enter the answer to this question. Okay. So I'm sorry we don't have too much time to discuss specific questions in great detail. We'll keep it going in the future. I mean, you can carry on in the discussion forum of the course. Your instructors will help you there to answer these questions. Okay, so this is 10,000. Don't put the answer in the chat box. Just try to keep the chat box as clean as possible. Put only doubts you have in the chat box. So you have to go to joinpd.com, then okay. So don't put the answer in the chat box. Oh, exactly what I asked people not to do. People end up doing. Enter the answer in joinpd.com. There is a box where you have to put in the answer. Once you're done, you can put it there. That will help me look at what's going on, get a sense. I'll get a sense of how many people are getting the correct answer, how many people are not able to answer, etc. Okay, one more minute to go. Please put in your answers. Okay. So there's no posting in joinpd.com. The answer will come. You just have to enter the answer. That's enough. It gets registered. All right. So now the time has come to see the answer. Oh my God. This answer is difficult to read here. This it doesn't show properly. Let me show it on the grid layout. The grid layout. This is better. So quite a few 560s and 560 with 3 zeros. Okay, the answer is in thousands, right? So you shouldn't miss out the thousands, but quite a few people have got it. The 560, 56, I see quite a few answers in the right. 560,000 or 5,60,000 is the correct answer to this question. So quite a few have got it, and a lot of people have entered 560. I think that's because they forgot that this answer is in thousands. So that's okay. All right, let's now see how to go about answering these kind of questions. So everything relies on this thing. So the solution depends on this idea. It turns out, given the roots of the polynomial and given a little bit of more additional information, you can find the polynomial. Okay, so that's the central idea. So let me just go through the 3 steps. In the first step, you collect all the information you know about the cubic polynomial P of t, right? So the polynomial P of t, which represents the profit of that company. The coefficient of t cube is given. The leading coefficient is given, that's 10. And what's given is at 3, at t equals 3, P of 3 you have 0, P of 6 you have 0, P of 8 you have 0. So you have roots 3, 6, 8. Okay. So it turns out there is a form for any polynomial P of t which has all roots given. So for instance, a cubic polynomial, if you give 3 roots a, b, c, you can write the polynomial itself as the leading coefficient times t minus a multiplied by t minus b multiplied by t minus c. Okay, so this is the central idea. Once you get this form, everything is very easy, right? So a, b, c, 3 roots are given. T minus 3 times. Oh, am I audible, Balaji? Can you hear me?
Yes, sir, you're audible, sir.
Okay, so t minus 3 times t minus 6 times t minus 8 times the leading coefficient 10, and that's the cubic polynomial. That's it, right? So once you get the cubic polynomial, it's just a question of putting in t equals 10, you get 560, the answer is 560,000. Okay, so the question I want you to answer in this slide is, supposing instead of saying, okay, so all this information is given, coefficient of, let's say, p power 3 is given as 10, and then instead of saying P of 3 is 0, P of 6 is 0, P of 8 is 0, suppose instead of 0, I give you other numbers. Let's say I say P of 3 is 1, right? Doesn't matter what it is, some number. P of 3 is 1, P of 6 is 2, and let's say P of 8 is minus 1. Okay, just 3 numbers. Instead of 0, 0, 0, I give you 3 other numbers for P of 3, P of 6, P of 8. Okay, I want you to type in the response in this page. Do you think you can solve the problem? Do you think you can find a P of t if I give you the coefficient of t cube and then I tell you P of 3 is some number, 1. Let's say, you just take it as 1 if you like. Okay, it doesn't matter. 1. P of 6, you say 2. P of 8, you say 3. I don't know. It doesn't matter what it is. 3 number. Do you think you can still find the polynomial exactly? Right? That's my question. Okay. Don't just say yes. I mean, you should also say a little bit about how you'll do it. Okay. So that's the question for this, and I will come to the chat box now and see if there's any questions that are there while people are entering the answer to that question. The profit after I'm supposed to find the 11th. Okay, no, the polynomial is defined like that. T equals 10 is for profit after profit or loss after the 10th year. And you can go read the question. It's mentioned like that. That's just what the thing is. Oh my god, people just keep typing in the chat box. I guess there's no way to sort of freeze the tax chat box and then look at the question. Okay. All right, so I'm not able to see anything interesting. The question I asked, please put the answer in the joint PD site. I'm going to go and look at it immediately. This is for questions on this, any doubts you may have on this question. Only for that, you use the chat box. It's better for me that. Okay, so not too many questions. So let me just quickly see the responses here. The responses. Now I understand the question. Right, the general equation put P of 3 equal to whatever given. Yeah. Okay. Right. I think most people have got the idea. If you put in the three values, you will get equations involving the three unknown coefficients, and you can solve for it, and you will get a unique answer. What's interesting is the last part I said. You will always get a unique answer. Whatever the value of P of 3, P of 6, P of 8 I give you, you will get a unique answer when you solve for that. That part maybe is a bit interesting for those of you who have not seen. Okay, so that's good. Before we close this session, so I'm going to ask you one question just to share, just to see quick temperature check, as they call it. Okay, if you look at this session, if you enjoyed it, drag the blue button into the green thumbs up signal. If you didn't like it, or you were in between, you were sort of like it, maybe not. You put it in different places. The closer you put it to green, the better you enjoyed the session. The closer you put it to red, you didn't enjoy the session. So that's what this means. So go ahead and do that. This will give us valuable feedback on how this session went. Should we continue such sessions? Is it useful? Etc. Etc. Please go ahead and put it in. Okay. So with this session actually comes to an end, but I'm going to be available for the next 15 minutes or so, and I think there are also other staff from the online degree team who are available. So if you have a question, you can raise your hand, and you'll be asked to speak, and we can go over the responses. Okay. So it's just a few minutes we have for questions. So we can't do too many questions. So please remember that. If there's a very nice question that you have which you think will be useful for everybody, please go ahead and raise your hand. We'll see it. Okay. Please put in your response for this temperature check. It's very useful for us.
Balaji, can you unmute one person so that they can start questions?
Yes, ma'am, done.
Who is unmuted, Balaji? I can't see it here.
Hello.
Yes.
Sir, am I audible?
Yes, I can hear. Go ahead.
Sir, actually, I live in Lucknow, and sir, the exam center which I was allotted for the quiz 1 and 2, sir, it was. Sir, can you, sir, if it's possible, can you, sir, please?
Can I please request? Don't ask questions that are so specific to just you. Please ask some more general questions. So
Okay, sir.
this specific question, please send an email to support. Okay.
Sir, I've sent an email.
Yeah. Thank you.
Please ask questions that are related to the content of whatever is being discussed, any doubts you have in the course. I think we should make better use of professor's time on this. The other questions we can take, or we can help you through support.
Hi, sorry, I have to repeat this, sir, Professor Andrew, sir. Thank you for the session. I have sent this email 3 times to the support team and I have not got the answer. And this is the same as the Lucknow person asked. And I've just requested whether you could share the list of centers available in the site so that people can give some feedback or lose it. So the last time I had to travel 1 hour 20 minutes within Bangalore, of course. So it is 1 hour 15 minutes to go and 1 hour 20 minutes to come back. So I'm sorry, I know this is a very specific thing, but probably does affect others. And for some reason, the support team has not been able to answer this.
Okay.
I will go off mute. Sorry, you could answer this later too.
No.
I'm not looking for an
Yeah.
answer now, but
I mean, the only comment I want to make is it's a valid question, but it's not the best of times, because we're hoping to have more of a technical discussion on topics in this session. Okay. So we will soon have an admin session where you can raise these questions. Okay. Please be patient with us.
It's Puneet here.
Yes.
Professor Andrew, firstly, thank you. Wonderful session. And I am old school, I'm retired, and I found your session to be much more helpful than a recorded video session. So my question is, could we have a similar pedagogy for all subjects after every week's material is uploaded? So we can watch the videos and then attend a session like this?
Okay. We are working on it. And if the feedback for this is overwhelmingly positive, everybody likes it, we'll go ahead and try and put something in place like this. Okay.
To the point. Thank you very much, sir. Have a good night.
Hello.
Yes.
Am I audible?
Yes, I can hear you.
Question, sir. In the video lecture, to find the polynomial, so suppose f of x plus g of x divided by h of x, then there they shows ki take the highest degree of polynomial out of f of x and g of x, and then it is divided by the denominator h of x. But here you are applying the division rule. This confused me a little.
Oh, okay. So, okay. So you're saying when you add, when you do f of x plus g of x and then divide by h of x, and you want to find the degree of what? Degree of the quotient or the remainder?
Now, degree of the
Degree of
polynomial
quotient.
when
So degree of the quotient is going to be what you said, right? The maximum of the degree, I mean the degree of the numerator minus the degree of the denominator, right? That will be the degree of the quotient, q of x. The question asked is degree of the remainder, right? So that's a different question. So it's going to be less than the degree of the denominator, but what exactly it will be is depends on the actual polynomials, right? So in this question, there's some information given, not directly, but sort of, it says partially, okay, there's this f of x, which is h of x actually divides f of x. And then there's this g of x, whose degree is less than the degree of h of x. So that's partial information sort of given to help you. And then you have to put all this together and find what will happen when f of x plus g of x gets divided by h of x, and not the quotient. We are not interested in the quotient. We are interested in the degree of the remainder. Okay. So it's a slightly different question, right? So if you think about how the remainder will come in, so you have to use other ideas. Ideas like, what happens when you divide, when it divides exactly, what happens to the remainder. When the degree is lesser, what happens to the remainder. When you add, can you individually divide and then take the remainders and do something and get the overall remainder? You have to use different ideas. That's all. Okay.
correct, sir. The coefficient to find the polynomial coefficient, we will apply the earlier one, and to find the remainder, that's what you shown here. That is fine.
Yeah.
But once I know this, how to find this remainder through these steps, suppose I am giving fx is equal to x to the power 4 and g of x is equal to x square and h of x is equal to x square. So if I go by the earlier method, then x square takes common, the quotient becomes 1 plus x square. And there asks me to choose the graph of 1 plus x square, which is a parabola. But if the degree of highest degree of polynomial and the lowest one get cancelled out, they are saying that this is a constant term and showing a straight line. How this is come? This is where I get confused, sir.
Okay. So for instance, if the numerator is x squared, so let's say 3x squared, okay, and the denominator, like you say, you're dividing by something which is say 2x squared, right? So you're dividing 3x squared by 2x squared. What would happen? That's the sort of situation where you will get a constant, right? That's where you will get a constant. That's the
no, sir.
meaning.
I'm telling f of x plus g of x by h of x, where f of x is equal to x to the power 4 and g of x is equal to x square.
Okay, so then you x square, then you will not get a constant. You will get 1 plus x square as the quotient, right? And the remainder is 0, right? So you get 1 plus x square. You will not get a constant. Remainder will become 0.
Exactly, sir. But in the option that the problem that they're given, okay, I will take a picture and write it. Where is my confusion,
Yeah.
and then I
So
mail it to you.
yeah. Okay. You can mail it in the discussion forum of the course. You'll get
Okay.
good answers. Okay. Okay. Thank you.
Hello?
Yes.
Yes. Thank you for the session, sir. I had a question with regards to the second quiz. I didn't get one of those questions and I've been trying to solve it. Is that okay if I ask you this question now?
Yeah. Give it a shot. Let me see. I may not be that familiar with it, but yeah, sure.
Okay. So the question, it's the one where they've given us A, B, C are the roots and the polynomial is x cube plus fx minus 9.
X cube plus
Fx minus 9.
F. F is some unknown, is it? Okay.
X cube plus 5x minus 9. I'm so sorry.
Okay. Okay.
X cube
Okay.
plus
Sure.
minus 9. A, B, and C are the roots, and their sum is
Okay.
0.
Okay.
And we're supposed to find A cube plus B cube plus C cube.
Okay. Okay.
So I have gotten as far as finding out that A cube plus B cube plus C cube is 3ABC.
Okay. Okay.
But I don't know how to find the roots of x cube plus 5x minus 9 because it's
Okay, okay. So there are properties like the product of the root you can find without finding the individual roots, right? So if you have a
Okay.
polynomial like that, so supposing you write the cubic polynomial as x minus a into x minus b into x minus c, right? What is the
Okay.
constant term in that expansion after you multiply it?
Oh.
You will get
Oh,
minus abc, and that is equal to the constant term minus 9 in your original polynomial.
right.
That will be the
Okay,
answer.
okay. No. Thank you. That makes perfect sense.
Okay. That was easy enough, so that's an easy question. Okay.
Sir, good evening. This is Advi here. Thank you for the
Yes.
session. So I have a question in the activity
Sure.
that we had. So it is first one is AQ4, AQ7 fourth.
I wouldn't know the number, but I mean, if you
Yeah,
each other
sure.
describe the question, I'll
I'll just get the question. Yes, sir. So it's on question 2. So this is what they've given an expression, and from that they've asked what is the appropriate algebraic expression corresponding to graph in the polynomial. And the polynomial that I got was supposed to be an odd degree polynomial. And
okay.
one of the options I got it as an odd degree polynomial, but in the answer it is not given to be a odd degree one. So,
Okay. So, are you suspecting that the answers are incorrect, or you're thinking maybe your steps are not correct?
yeah, I don't know how to show the question to you.
Yeah. So this part, when you please ask in the discussion forum of the
Yeah, I mailed
course.
this in the forum also, sir.
Yeah. You will
And
get
there
a
is one.
response. You will get a
Okay,
response.
there's one more question that I have. When you
Hmm.
have solutions like x is equals to plus or minus, root of 4, you get plus
Okay.
or minus 2. So that will be considered as a root, right? In the graph, it will be one of the roots, right?
Yeah. So if you have an equation like x squared equals 4, or say the polynomial is x squared minus 4 equals 0, it
Mhm.
hits 0 at two places, when x is equal to plus 2 and x is equal to minus 2. So both are roots, definitely.
So, I think again in the option there is something wrong. Then okay, sir. I just
So
wanted to know
please
if
ask in the forum. Please ask in the forum. You should be getting an answer.
okay, sir. I've posted it, but I will just give it a try again. Thank you, sir.
Check the answer. Okay. So we can have maybe 2 or 3 more questions, and we should stop. It's already 55.
Hello, sir.
Yes.
Yes, sir. Thank you so much for this session. It was really great. So my doubt was about the stretch factor. So what is it, and like how do we calculate it?
Okay, I don't know what the stretch factor is, so maybe this is something that is discussed in class, and I mean I've not seen every lecture that's given on that one. Sorry. So what is the stretch factor? I mean, can you define it?
So that's what even I'm not getting actually.
So maybe, okay, I'll ask the instructors to provide some more details. Okay.
Yes. Yes, sir. And also, can you just explain once again as to the relation between the degree, as in if the degree of a polynomial is 3, then how many roots it will have, what will be its maximum multiplicity, and
Okay.
like that.
Okay. So for a polynomial with say real numbers as coefficients, if you have degree n, let's say degree 3, let's take degree 3. 3 is a good example. Okay. It will have 3 complex roots, okay, complex number root. So that's the correct and complete sort of picture. But we don't really study complex roots in this class. But still, that's the main idea. So it's got 3 complex roots. That's always true. And you may have repetitions, as in all the 3 roots may be the same. Like x minus 3 whole power 3. Okay, it's got only one root, just 3, but it occurs 3 times, right? X minus 3 into x minus 3 into x minus 3. So it occurs 3 times. That's multiplicity of 3. So with multiplicity, the number of roots, if you say complex roots, it's equal to 3. Okay, but what will happen is, because the polynomial has real coefficients, you cannot have exactly one complex root. If you have one complex root, then if you look at the constant term, it will become complex, right? It's a product of 3 things, and the j or I will not go away. So it will also have, so when every time you have a complex root and the coefficients are all real, the conjugate of the complex number will also be a root. Okay? They'll come in pairs. And so the situation is, you may have 3 real roots, or you may have 1 real root and 2 complex roots. Okay.
Okay.
Now, when I
And
say
so
any number, it's with multiplicity. You can count with multiplicity and say. So you may have 1 real root or 3 real roots, and you will always have 3 complex. Okay, hopefully that sort of captures the picture.
and so that we'll have n minus 1 turning points, right?
Okay, so now it depends on the number of multiplicity you have. So for instance, have you seen a plot of x power 3? Just x power 3.
Yes, sir.
Right? How many turning points do you think it has? X power 3, there is no, I mean, it hits 0 only at 0, right?
Yes, sir.
And even at 0, it's not really a proper bend, it sort of has a saddle, right? It comes from the negative side and flattens out at 0, and then flattens a little bit and then takes off, right? So it's like a saddle, saddle, you know what saddle is, right? It's on top of your horse or something. It's like a saddle in that point, right? It's not a proper upward peak or bottom, right? It's not a turning point. So x cube, some people will say, it doesn't have a proper critical turning point, right? So critical points are not there for x cube.
So we won't consider that as a turning point, right?
Yeah. So you may have, you can consider that as sort of like, people say saddle point for that. So various terms are there, but you can have a polynomial with no bends, right? It's not a bend, in the way we define a bend. So it's possible to have no bends also. So that can also happen for a cubic polynomial.
So
but
for turning points,
if it has distinct roots, if it has 2 distinct roots, it will have 3 distinct real roots, for instance, then it will have 2 bends, right? It has to have 2 bends in the middle. That's the way it is. Okay.
Yes. Okay. Got it. Thank you so much.
Okay. So I think we've run out of time. We can't take any more questions. Thanks a lot once again for being with us. Let me just stop sharing my screen, and I'll also close this lesson that we have here. Thank you very much for being with us. This is a session that I enjoyed being with you. I hopefully you also enjoyed being with us here. Let's see if this session enough people found it nice and they recommended that we continue. We'll try and do this for other subjects as well. In fact, tomorrow afternoon, 2 o'clock, we're doing a similar session on statistics, and I will be running that session as well. And then on Sunday, maybe somebody
No, tomorrow morning at 10 a.m. Okay. Tomorrow morning, 10 a.m.
Tomorrow morning at 10 a.m. Yeah.
It's on CT. Yeah, Jay Krishnan is doing it on CT.
Okay. So we are doing similar sessions. Please do participate and benefit from it. Okay. Thank you very much, and good night.